Hello, Algebra 2. We'll be talking today about Edgenuity Section 8-2, which is called Radian Measure. We're going to have a couple objectives for this. The first is to convert between degree and radian measure, and the second is to use the definition of radian measure to calculate arc length, radii, and angle measures. Let's look at our first problem. We want to convert 7/9 pi, or 7 pi over 9, however you want to think of it, to degrees. And the big thing that we're going to do, the big key to this, usually when we talk about radians, we talk about a circle, okay? And we talk about a circle with a radius of 1, and the key is that 180 degrees of rotation is pi radians of rotation. I'm not going to talk about exactly how that works in this video, but it's something that I could go into a lot greater detail in if anybody wants to ask me about it. So the key then is that pi radians equals 180 degrees. And this is what we're going to use to do all the conversions. This one basic fact is going to get us everywhere that we need to be. Now, in a problem like this, where I have pi right in the problem, the easiest way to do this, the most straightforward way to do this, is to say, well, that pi, this pi right here, is 180 degrees. So instead of writing pi, I can just write 180 degrees. So 7/9 pi equals 7/9 times 180 degrees. And all I have to do is simplify that. So then I can say that's 7 times 180 degrees over 9, and I can focus on this 180 over 9 because 180 divided by 9 is 20, that is 18 divided by 9 is 2, and then you tack a 0 on the end of it. So this is like 7 times 20 degrees, and 7 times 20 is 140, 7 times 2 is 14, and tack a 0 on the end. So we get 140 degrees as our answer. I'll give you a moment to look at that. And let's look at the next problem. Now we want to start with degrees and turn them into radians, and I am going to use the exact same fact to do that, the fact that pi radians equals 180 degrees, okay? And so the way we're going to do this is, imagine, instead of thinking of it as negative 135 degrees, think of it as negative 135 times 1 degree. That is, if I did negative 135 times 1 degree, I would get negative 135 degrees, okay? And what I'm going to do is I'm going to take this here, and I'm going to solve it for 1 degree, and then I'm going to make a substitution right there. So I'm going to divide by 180 on both sides, and I'll get pi over 180 equals 1 degree. And now I have something that I can substitute for the 1 degree. So this is negative 135 times pi over 180 radians. And then I can mess with this a little bit. I'll take this, multiply it to the top only, and have negative 135 times pi over 180, and I will focus on reducing that 135 over 180, okay? I know they both can reduce by at least 5, right? So I've got negative, and then 135 divided by 5. Maybe I can do that over here. 135 divided by 5. I'll make a little work box here. Would be 2. That would be 10. Subtract, and I get 3. 35. So that's 27. So now we've got 27 pi over 180 divided by 5, which will be 3, which will be 15. Subtract, and I get 3. Bring down the 0, I get 30. Whoops. 6. So over 36. And you should be able to see that both of these numbers divide by 9. So let's reduce again, this time by 9. If I do 27 divided by 9, I get 3. And pi is still there. And 36 divided by 9, I get 4. So negative 3 pi over 4 radians is what is equivalent to negative 135 degrees. All right. I'll give you a moment to look at that. All right. Let's look at the next problem. Convert 4.3 radians to degrees. So let's go back. We'll say again. Pi radians equals 180 degrees. And this time, so now this is like having 4.3 times 1 radian, right? So what I'm going to do is I'm going to take this and I'm going to solve it for 1 radian. So I'll divide by pi, and this will be 1 radian equals 180 degrees over pi. And then I will take this and substitute it in there. So this is 4.3 times, instead of 1 radian, like that, I'm talking 180 degrees over pi. So that's 4.3 times 180 degrees all over pi, and at that point you can take your calculator, put it in. You can do, I don't know, what's 4.3 times 180 degrees. I'll put that into a calculator. 4.3 times 180 is 774 degrees over pi. And then I could divide that by pi, or an estimation for pi if they tell me to use that, whatever. If I divide it by like the calculator, the scientific calculator pi symbol, I get 246.4. Let's keep it at the same decimal places. Degrees. So it is approximately 246.4 degrees. Approximately. Keep a close eye always on what they tell you to use as far as approximations or non-approximations. Really, this answer is a good answer. It's the most accurate answer. It is the exact answer, actually. But Edgenuity and other educators and stuff want you to put things into a calculator. I'm not really sure why. Putting things into a calculator is stuff that everybody knows how to do, but I suppose there's some value in knowing how to put things into a calculator. All right, so let's compare 120 degrees and 5 pi over 6 radians. Let me do this visually first and show you kind of how to split things. If I'm going to do 180 degrees, okay, let's say we start here, and I'm going to rotate 120 degrees, which is 60 degrees less than rotating 180 degrees. So if I did 180 degrees, that would be like straight across, right? But, so if I go 60 less than that, like that, I call that 120 degrees. I can look at it that way, okay? Now, how do you do 5 pi over 6 radians? Well, you use the idea that 180 degrees is pi radians, right? So, the top, each half of the circle takes up pi radians. So there's 2 pi radians in a full rotation of the circle. So that much is pi radians. So if I'm looking at sixths, that is to say I take half of it and divide it into 6 equal parts. There's 2 equal parts, and then if I divide each of those into 3 equal parts, I have 1, 2, 3, 4, 5, 6. And each of those then is a pi over 6. So I could label each of these as 1 pi over 6, or just pi over 6, and 2 pi over 6, which I might reduce to 1 pi over 3, and 3 pi over 6, which I might reduce to 1 pi over 2, and 4 pi over 6, which I might reduce to 2 pi over 3. I'm getting a little crowded here, but you get the idea. Okay, so there's 4 pi over 6, and look, we've got 5 pi over 6 right there, and then the next one would be 6 pi over 6, or pi, right? So how do these two compare? Well, it's really hard to compare them visually. They almost look like they could be in the same spots, especially if I'm just sketching things out. So let's, again, use the fact that pi equals 180 degrees and compare them. And really, the easiest way to compare them is to make the substitution right there, right? So let's compare 5 pi, or 5 times 180 degrees, over 6. And let's convert that to degrees. Let me focus on 180 over 6, because 18 divided by 6 is 3, so 180 divided by 6 is 30. So this is 5 times 30 degrees, not over 6, because I've divided by 6 now. And then 5 times 30 is 150. And so one of them that I'm looking at is 120. One of them that I'm looking at is 150. Always point at the smaller one when you're writing inequalities. And so we get that 150 degrees is greater than 120 degrees, or 120 degrees is less than 150 degrees. Or, in other words, that 120 degrees is less than 5 pi over 6. Which you can sort of see, the 120 really only comes to there, it turns out, and the 5 pi over 6 comes almost all the way around. All right, I'll give you a chance to look at that. All right, let's look at the next one. Now we're going to talk about arc length. So we're going to say a circle has a radius of 10 inches, and we want to find the arc length for a central angle of 2 pi over 3 radians, which turns out to be right about there. Okay, central angles always look like this. They start with a radius from the center and rotate around. If you rotate that way, you're rotating in a positive angle direction. If you rotate that way, you're rotating in a negative angle direction. So this is 2 pi over 3 radians, and the beautiful part of being given radians in this scenario is that we have a really ridiculously easy formula. We have arc length, which is represented by little s, and I tend to write it with a cursive lowercase s, mostly because sometimes when I write s's, people are like, why'd you write a 5? So this is just to avoid that confusion. So s, the arc length, equals the radius times the angle in radians. So r is the radius, and this is lowercase theta, and it is the angle, or maybe I should even say the central angle, in radians. So I can use this real easily if I am given or convert the angle that I'm given into radians. So this is then really easy to figure out, right? The arc length is the radius, 10 inches, times the arc length, 2 pi over 3 radians, which is then, well, 10 times 2 is 20 pi over 3. And this will still be in inches because radians are what we call a unitless measure. So there is our answer, and of course we could put it into a calculator if it asks us to, but I'm going to leave it like that and leave you to put it into a calculator. I'll give you a chance to look at that for a moment. All right, let's go on to the next problem. Let's find arc length. So this time I'm given a picture and I'm given a central angle. So my central angle this time is 200 degrees. So that's going to be an issue that I have to deal with. Let's call that 200 times 1 degree. Let's remember that pi radians equals 180 degrees. If I divide by 180, I can find 1 degree. Pi over 180 equals 1 degree. So I can make a substitution here. 200 times pi over 180. So then I have 200 pi over 180, and I can concentrate on reducing that fraction, and I can divide them both by 10 and just cut out that 0 there. And then 20 over 18 can reduce by 2 to 10 pi over 9 radians. So now I can use my arc length equals r theta, because now I have theta in radians. So arc length equals the radius, which is 15, times the arc length, 10 pi over 9. And then I could do 15 times 10 is 150 pi over 9. And then 150 and 9 can both reduce by 3. So this would be 50 pi over 3 inches. And again, you could put it into a calculator if I asked you to, but I'm going to leave it that way. I'll pause for a second, let you look at that. And let's go on to the next problem. So a circle with a central angle measuring 90 degrees. Okay, so a circle, the central angle measuring 90 degrees. So there's our angle. For an arc length, so arc length is how far we would have to travel if we were walking along the circle to get from the beginning of that arc to the end of that arc, is 117.75 inches. And what it wants is for us to figure out the radius of this circle. So the thing that we have is S equals R theta, but again, theta has to be in radians, and right now our theta is in degrees. So let's have 90 times 1 degree, and pi radians equals 180 degrees. So if I divide by 180 on both sides, I can do pi over 180 equals 1 degree, and I can make this substitution. So 90 times pi over 180. And then I have 90 pi over 180. I can focus on the 90 over 180 fraction. Divide by 10, and I cut out the zeros. And 9 over 18 reduces by 9 to 1 over 2. So this would just be 1 times pi is pi over 2. So this is our angle now in radians. So now I should have everything that I need. I've got the arc length. It's 117.75. I don't know the radius, but I do know the angle is pi over 2. So what can I do here? Well, 117.75 equals, if I take this r times the pi up there, I can do this in 2 simple steps instead of one more complicated step. So r times pi over 2, and what I'll do is multiply by 2 on both sides so that I cancel the 2's because I'm dividing by 2, so to get rid of it I multiply by 2. And then I need to figure out 117.75 times 2. 2 times 5 is 10, carry the 1. 14, 15, carry the 1. 14, 15, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2, and 2 decimal places gives me 235.50, or just 0.5, equals r times pi. And then I'm looking for r, so I'll divide by pi on both sides, trying to get r by itself. And so I've got 235.5 over pi equals the radius, which I could then, I'll put this into a calculator, and we'll see what we come up with. That'll be, let's see here, 235.5 divided by pi. And again, I used the pi symbol on my scientific calculator, just on my phone, and that gives me a radius of approximately 74.96 inches. So that is the approximate radius. And again, pay close attention to how they want you to calculate that. But that is finding radius using the arc length formula. I'll give you a moment to look at that. And that is our last problem of this lesson. So I hope this was informative for everybody. Thank you.